This is my third video lesson for Unit 12. In this lesson, we'll be talking about how equilibrium responds to temperature and pressure changes. Go to page 9 in the class packet. Motivation. Increasing temperature or heat will favor which side of this chemical equation? Let's first identify which direction of the reaction is endothermic and exothermic. From left to right, energy is being absorbed and is on the reactant side. Therefore, it is endothermic, going from left to right. The reverse reaction, from right to left, is exothermic because energy is being released. Since we're increasing temperature or heat, we're adding energy in the system. So where would equilibrium shift? Which side of the equation will be favored? From the previous lesson, whenever we add or increase something, equilibrium shifts to the opposite side. Since energy is on the reactant side in this equation, it will shift to the product side, which is the endothermic reaction and direction. Learning target. At the end of the lesson, I will be able to explain how temperature and pressure influences the equilibrium in a reaction using Chatellier's principle. In the previous lesson, we talked about Chatellier's principle in terms of concentration. In this lesson, we'll be focusing on temperature and pressure. Homework B number 3, which be a Junipod based off this lesson. There will be a quiz Junipod on PowerPoints 1, 2, and 3. We're first going to talk about the temperature stress. Here we're given two chemical equations. Let's first identify where energy is in the equation. Energy is on the reactant side in the first equation, while energy is on the product side in the second equation. Next, we identify which direction is endothermic and exothermic. In the first equation, endothermic is from left to right because energy is on the reactant side, is being absorbed. So the forward reaction is endothermic, so the reverse reaction is exothermic. Let's look at the second equation. Since energy is on the product side, the endothermic process is from right to left. Since the reverse reaction is endothermic, the forward reaction will be exothermic. Increasing temperature or heat shifts to the opposite side of the energy in the chemical equation or the endothermic direction. So how does this restore equilibrium? When temperature increases, the extra heat is removed by doing the endothermic reaction. This counteracts the change and restores equilibrium. Decreasing temperature or heat shifts to the same side of energy in the chemical equation or the exothermic direction. So how does doing the exothermic reaction restore equilibrium? When temperature decreases, the extra heat is produced by doing an exothermic reaction, which counteracts the change and restore equilibrium. Let's look at our first example. Here we're given a chemical equation. Energy is on the reactant side on this equation. When we increase temperature, we're adding energy. Since energy is on the reactant side, it'll shift to the opposite side, which is the products. Since chlorine is on the reactant side, it would decrease. Since water is on the reactant side, it will decrease. Since HCl is on the product side, it will increase. O2 is on the product side as well, it will increase. When the temperature decreases, energy is being removed. Since energy is being removed, it will shift to the same side, which is the reactants. Since chlorine and water is on the reactant side, they will increase. HCl and O2 is on the product side, therefore they will decrease. Learning check number 1. What will be the result of an increase in temperature at constant pressure? Pause the video and resume once completed. Since energy is on the reactant side and we're increasing the temperature, equilibrium will shift right. It will favor the opposite side of energy in the chemical equation. Therefore, the concentration of NO2 will increase. Choice 4. Learning check number 2. Which changes occur when temperature of this system is decreased? Pause the video and resume once completed. Since energy is on the product side and temperature is decreasing, the equilibrium will shift to the same side of energy, which is the product side. Therefore, the concentration of H2 will decrease, concentration of NH3 will increase. The answer is choice 4. Try to do questions 2 to 7 on your own. Pause the video and resume as completed. Here are the answers. In the second half of the lesson, we'll talk about the pressure and volume stress. Note this only applies for gas only. From the gas unit, what was the relationship between pressure and volume? It was an inverse relationship. So here we have a chemical equation. Which side do you think will have more pressure and why? To figure this out, you have to count the number of substances that are gases in the chemical equation. On the reactant side, there are 4 molecules that are gases. On the product side, there are 2 molecules that are gases. Since the reactant side has more molecules, it will exert more pressure. To help you understand how pressure is going to affect the equilibrium, let's look at this analogy. Let's say you're getting on the bus. The front of the bus is very crowded, but the back of the bus is not. Since the front of the bus has so much people, there's a lot of pressure. You will want to move to the back of the bus where there's a lot more space. It is the same idea here. Increasing the pressure will favor the side with less molecules. Less pressure will favor the side with more molecules. So increasing pressure shifts to the side with less gas molecules. Why? If you're adding pressure, you want to shift to the side with less pressure to counteract the change. If there are less gas molecules, they will exert less pressure. Decreasing pressure shifts to the side with more gas molecules. Why? If you're removing pressure, you want to shift to the side with more pressure to counteract that change. If there are more gas molecules, they will exert more pressure. Here is a diagram to help you visualize this. On the reactant side, there are 4 molecules in total. On the product side, there are 2. So when pressure is exerted, the reaction will produce products in order to restore equilibrium. Here's a GIF. Let's look at the first example. Here we have a reaction at equilibrium. Since the question involves pressure, we have to count the number of gas molecules. On the reactant side, there are 2 molecules that are gases. On the product side, there are 3. When we increase pressure, we're going to favor the side with less gas molecules, which is the reactant side. Since water is on the reactant side, it will increase. Since oxygen is on the product side, it will decrease. Since energy is on the reactant side, it will increase. Since hydrogen is on the product side, it will decrease. Let's look at the next scenario. Here we have pressure decreasing. If pressure is decreasing, you favor the side with more gas molecules, which is the product side. Since water is on the reactant side, it will decrease. Since oxygen is on the product side, it will increase. Since energy is on the reactant side, it will decrease. And since hydrogen is on the product side, it will increase. Learning check number 3. If the pressure on the system is increased, the concentration of CO2 gas will do what? Pause the video and resume as completed. Since the pressure is increasing, you favor the side with less gas molecules. On the reactant side, there are 5. On the product side, there are 4. Therefore, it will favor the product side. Since CO2 is on the product side, it will increase. Learning check number 4. As the pressure increases at constant temperature, the amount of CO2 gas will do what? Pause the video and resume as completed. Since pressure is increasing, you're favoring the side with less gas molecules. On the reactant side, there are 0 gas molecules. On the product side, there is 1. Therefore, reactants are favored. Since CO2 gas is on the product side, it will decrease. Answer is choice 1. Learning check number 5. Which conditions will yield the most product? Pause the video and resume as completed. Since you want to favor the product side, you have to increase the temperature since energy is on the reactant side. And since there's 3 gas molecules on the reactant side and 1 gas molecule on the product side, you also need to increase the pressure. The answer is choice 3. Try to do the rest of the questions on your own. Pause the video and resume as completed. Here are the answers. Here is a summary table of this lesson and the previous lesson. Use it to study for the exam and for the regions. This concludes the video lesson. Remember to do the Juniper homework and quiz.